Okay, so starting with circles, the formula that I like to use for finding length of an arc and sector area are these. So for arc length, we use the formula theta pi r over 180, where theta stands for the angle that you're given, and r stands for the radius of the circle. So this is arc length. Okay. For sector area, we use theta pi r squared over 360. Okay. Once you know those formulas, solving these problems isn't that difficult. It's just a matter of plugging things into a formula. So for example, for 26a, my angle is 90 degrees for arc AB, okay, and my radius is 6. So we've got 90 pi times 6 divided by 180 gives us that the arc length is about 9.42. Okay, and then for sector area, we would have 90 pi 6 squared over 360. Okay. And that gives us about 28.27. Okay. Okay, so I'll do one more example. Okay. We've got 26b. So once again, our angle is 130. Okay. Pi times 9 over 180 for arc length. So that's about 20.42. And for sector area, we would have 130 pi 9 squared over 360, which gives us about 91.89. Okay. 27. In circle A, the measure of arc CD is 128, and it wants us to find the measure of CAD, this angle here, and the measure of CBD, this angle here. So this is a matter of knowing two things. First, if an angle is central, meaning that its vertex is at the center of the circle, it will be the same measure as the degree of the arc that it intersects. Okay? So that would mean in this case that CAD, this angle, is equal to 128. Now, if an angle is inscribed, on the other hand, and inscribed means that the angle, its vertex, lies on the edge of the circle, okay, then it's going to be half the measure of the arc it intersects. So I would take 128, divide it by 2, and that would give me the measure of CBD is 64 degrees. All right. The rest of these problems are pretty similar to that. As long as you know that central angles are the same and inscribed angles are half, you should be able to solve these other kinds of problems. Okay. So over on the other side, we've got equation of circle questions. So the equation of a circle is written in the format x minus h squared plus y minus k squared is equal to r squared. Remember, we learned about how this format sort of mimics the Pythagorean theorem. This is like your a squared plus b squared equals c squared. Okay. All right. So we're given that our center is at 2, 3. Okay. And we have an endpoint at 2, 8. Okay? All right. So in this format, H and K represent the X and Y coordinate of the center, whereas R represents your radius. So anytime you're writing the equation for a circle, you need to know two things. What is your center and what is your radius? So easy enough, okay? This question gave us our center. So our H would be 2 and our K would be 3. Now if this is an endpoint on the circle, that means if I connect this line, this is our radius for the circle. So I can just count the distance, 1, 2, 3, 4, 5. Okay. So this circle has a radius with a length of 5. Just to kind of show you what it looks like, I'm going to extend this out. So we've got 1, 2, 3, 4, 5. There's another point, another, and another. So this is kind of what that circle looks like. Okay? All right. So then plugging things in, we've got x minus 2 squared plus y minus 3 squared is equal to 5 squared, which is 25. And you do want to go ahead and square the number because you will see it written in this format where it's actually your squared number. Okay? And that's our equation. All right, so scooting down, okay. Here we have some questions about 2D figures. Okay. So it says, below are 4 circles inside a square. The radius of each circle is 3. How would you find the area of the shaded region? So this is going to follow the basic idea that if I want to get the area of the shaded region, I would take the area of the square and subtract all of the circles. And that would give me what's left, which is the shaded piece. Okay. All right. So if each circle has a radius of 3, that would mean that the square would have to have side lengths of 3 plus 3 plus 3 plus 3, which is 12. Okay. So finding the area of the square, 12 times 12, would mean that the area of the square is 144. Okay. Now I would need to subtract the area of the circles. So for one circle, the formula for area of a circle is pi r squared, and that is on your formula chart. You just need to know where to look for it. So you look at area, okay, circle, pi r squared. All right, so plugging that in, pi times 3 squared, and that's equal to 28.27. Okay. Oh, they left it in terms of pi. Okay, well, if I wanted to leave it in terms of pi, then I would just square this number without multiplying it by pi. So 3 squared is 9. Okay, so this number is the same as 9 pi. And once again, you could just convert these answers to numerical answers. So like if I wanted to do that, I would just do 144 minus, type it in exactly like they did. Sorry, y'all. Okay, and that'll give me a numerical answer. So if I want to do everything in terms of decimals, give me just a second, I gotta answer this. Okay, so what were we doing? Okay, so we had one circle is equal to 9 pi. So that's the area of one circle. So you have 4 circles, right? So we would just have to take this 9 pi and multiply it by 4. Okay? So if we were leaving everything in terms of pi and kind of unsolved, the idea is that we would take the area of the square, which is 144, and subtract 4 times the area of one circle. So 144 minus 4 times 9 pi. So that's A. Okay. Now, of course, like we said before, If you don't like that, then just solve it like a normal problem. Okay, so maybe I got this 28.27. I know I've got to multiply that by 4 because I've got 4 circles. Okay, then I know that I need to subtract 144 minus that. Okay, so I know my answer should be about 30.92. This, just go to your answer choices, type it into the calculator, and you'll get those decimal answers, and then you can pick whichever one matches yours. Okay. All right. Same kind of song and dance for number 39. This time we have 2 semicircles inside of a square. How would you find the area of the shaded region? So same idea. You're still going to need to subtract the square minus the circles to get the shaded region. The difference this time is that we have half circles. So if you have 2 half a circles, that's going to total to just 1 circle. Okay. And since we're given the lengths, the size of the square are 10, that would mean that the radius of each circle would be 5. Okay. So I would need to find the area of the square, so 10 times 10 is 100. That's why all your answer choices have 100. Okay. And there's only 1 circle, so the formula for that circle would be pi times 5 squared. Okay. Notice that's not in any of our answer choices. That's because they went ahead and squared this 5. Okay. So 5 squared is equal to 25. So really this is 100 minus 25 pi. Answer choice A. Okay, flip over to the very back, the very last page. Okay. All right, we're going to take a look at number 42. So this one wants us to find the total surface area of this composite figure that consists of a cone on top of a cylinder. Okay. So if we're not including the base because it's sitting on its base, okay, then what we're going to need to add is the lateral surface area for the cone plus the lateral surface area for the cylinder. Okay? You have formulas for these. For cones, the lateral surface area is written as pi RL. Okay, so we're going to go ahead and get this part. So our slant height is given to us, it's 5. Our radius is given to us is 3. So pi times 3 times 5. And that's equal to 47.12. Let's see what I put in the calculator. Okay. For the cylinder, okay, we've got 2 pi RH, so that's our lateral. Okay. So for the cylinder, we have the same radius of 3, but we actually have a height of 8. So 2 pi times 3 times 8 gives us 150.796. So I'm going to round that to 150.8. This is what I get in my calculator, as you can see. All right. So this is the top portion, the cylinder is the bottom portion. If I want the total, I just got to add them. So 47.12 plus 150.8 gives us 197.92. All right. The last 2 problems that I'm going to complete are numbers 43 and 45. Okay, so it says the dimensions have been changed by 1 or more scale factors. Determine how many times larger the second figure is from the first figure by the indicated measurements. Okay, so comparing these two, going from y to 2y, we're multiplying by a scale factor of 2, and going from x to 3x, you're multiplying by a scale factor of 3. So what we learned in class is that when you have an unproportional dilation, where your scale factors are different, if you want to figure out how much larger the area is going to be, you multiply the scale factors together. So that would mean that this area is 6 times larger than this one. Okay? And it's the same kind of process for problem number 45. So we need to look at our scale factors. So going from 4x to 12x, 12 divided by 4 means that we would be multiplying times 3. Okay. Going from 3x to 6x means that we're multiplying by 2. So to figure out how many times larger my area would be, I multiply my two scale factors. 3 times 2 gives me, once again, my area would be 6 times larger. Okay. All right, I want to leave the rest of the problems for you to work on your own so that you have some own practice, individual practice on it. And I really do wish you the best of luck on your TEKS test. It is our last test for the report card, besides the final, which some of you are exempting. So do your best on it, and you're almost done with geometry.